Hi, uh, I'm going to show you the demo of the implementation of CNN accelerator on ZYNQ's FPGA 7000, and we have a Z board here, as you can see, and I'm going to show you how is it programmed and how we're going to run the post-processing and pre-processing to get the final output. So this is the terminal space where we are going to run the script for our entire pipeline from pre-processing to running the hardware, programming it, and also to post-process it. Now, since we are running it on bare metal, uh, we are not going to use a OS, and I have to unfortunately say that we need to download the ELF file every single time we are going to run the pipeline. But nonetheless, we have already achieved a speed up of 10x, which means the hardware accelerator runs at, let's say, in milliseconds, uh, 500 plus milliseconds. So that's cool enough. Still, let's go ahead and run the script. And before that, this is where we are going to check our final output, and this is the putty, or this is the console output that we are going to check. So let's go ahead and run the output. So it is starting the hardware server now, and then it is going to ask you which image to select. So these are all stored in one folder called as YOLO images, and you upload all your JPEG format only images in that folder, and you select what image you want to run according to whatever you want to see here. So let's say you go to doc.jpg, which is one of the most common ways, one of the most commonly used images. Let's go ahead and run it, and once we do that, it's going to copy that into our folders, run the pipeline, and give us the predictions. So for now, since it is running the first time, it is going to build the project with the help of this make file, and it takes a little bit of time. Now that the build is complete, as you can see, it is programming the FPGA. You can also see the blue color on the FPGA board. Now what is it doing is, through the JTAG cable, it is going to download our ELF file to the FPGA, and um, through the same JTAG cable, it is going to give us the layer outputs, which we will calculate in post processing. But the initialization of different components of the hardware, along with calculation of the speed or the time at which it is only the hardware is running, will be displayed in the console output through the UART cable. Okay, so as you can see, it is downloading the ELF file. It takes nearly 1 minute 10 seconds or 13 seconds. So it has taken the image output from the bin file that is stored in the FPGA, read the bin file, converted into a text file, and then displayed the predictions here. It says car 50% and truck 60%, and it gives us the position of wherever the values are displayed. Along with it, like I told, in the hardware, whatever the sub parts of the hardware that we've written in the HLS code, which is convolution top, max spool top, YOLO top, accelerator top, and then upsample top, and finally the DMA top. Along with these switches of the axis, we are going to initialize all of them, and 5,36,247 microseconds, which is nearly 536 milliseconds, is the amount of time it took for the hardware to calculate our values. So now let's check the final convolution output. So as you can see on the screen, this is your final convolution output. Let me see. It ran for this car and truck. It says car or truck here, and the bicycle is obviously over here, and then the dog over here. So this is the final output of how our accelerator runs. So thank you.